Hi! Today we're going to learn about initial conditions in calculus. So let's say we have a problem like this. If a car is decelerating at the speed of 12 miles per hour and the car is at 96 miles per hour at time t equals 0 seconds, compute the distance of the car traveled when it comes to a halt. So let's go back to something that we learned earlier on in the calculus course. We remember that the derivative of the position function is the velocity function, and the derivative of the velocity function is the acceleration function. And the derivative of the acceleration function, which would be the third derivative, is the jerk function. So we know that the derivatives go like this, so position to velocity to acceleration. However, in this problem, we're given the acceleration, or in this case the deceleration, so we're given that the acceleration is negative 12 miles per hour because it's decelerating, so negative 12 miles per hour. And we're given that the car is at 96 miles per hour at time t equals 0. So that means that we're given that when the time is equal to 0, the velocity is 96 miles per hour. So we're given a and v. Now we're given the whole function for a and we're given a point for v. So how do we do this? Well, here's where we compute the integral. So we know that the integral is the opposite of the derivative. So that means that the integral of the acceleration function is the velocity function, and the integral of the velocity function is the position function. So let's take a look at what this can do. So we know that the acceleration function is a constant negative 12. Because we know that the car is constantly decelerating at a rate of negative 12 miles per hour, or at a rate of positive 12 miles per hour, but it's decelerating. So, if a, and let's just say this is a of x, not just a of x is equal to negative 12. That means that the velocity function, or v of x, is equal to the integral of a of x, which is equal to the integral of negative 12, which would be equal to, the integral of negative 12 would be negative 12 x plus c, and this is equal to v of x. So here's where we learned something called initial condition. So we know that the c stands for any arbitrary constant value. But to go from those velocity function to the position function, we need to actually have a number here. So how do we find that number? Well, let's think of this function as a line. As you can see in this case, because this is a constant, this would be a linear line. So let's just graph a small line like this. So we know that it is going to be a decreasing line. So let's say the line went like this. Now, in the problem, we're given that at time t equals 0, the velocity equals 96 miles per hour. So that means that this point is equal to 0, 96. So that means that we can compute the value for c if we plug in the x value and set it equal to 96. So that means that we have to say v of 0 is equal to 96, which would be equal to, now we plug 0 into this function, negative 12 times 0 is 0, plus c is just positive c. So we get c is equal to 96. So now we know that because c is equal to 96, the velocity function would be equal to negative 12x plus 96. So take a moment to see how we got there. Now we'll erase it. Okay. And in this problem, we're also going to do another initial condition part again. So, have we answered the question yet? No. The question is saying to compute the distance of the car traveled when it comes to a halt. So we know that the distance of the car at time 0 is just 0. And to find the distance that it travels, we have to use the position function, because that tells us on the graph how far the car has traveled, or more accurately, where the car has traveled to what x value when the y value is equal to 0. It tells us how far it has traveled, and because we start at 0, 0, that also tells us the distance that the car has traveled. So, let's compute the position function. So p of x would have to be the integral of v of x. Oh, and it was supposed to be dx here. Whoops. Dx is equal to v of x dx, which would be equal to the integral of negative 12x plus 96, which would be equal to the dx. The integral of this would have to be equal to negative 6x squared plus 96x plus c is equal to p of x. Now, in this problem, we want to compute the distance that it takes, the distance that the car has traveled before it comes to a halt. And we know that the car comes to a halt when the velocity is equal to 0. So, when the velocity is equal to 0, we can set this equation equal to 0. So that means that, now let's bring it over here. Oops. This way. So this means that negative 12 times something, x, plus 96 is equal to 0, meaning that 96 is equal to 12x, meaning that x is equal to 8. So now we just have to plug in 8 into our position function, right? Well, how do we do that? We can't really do that in this case because we have c here. And we need to get rid of the c and put some actual constant there that makes sense in this problem. So how do we do that? Well, once again, we have to use our initial condition method that we figured out. So we know that at time 0, the car will have traveled 0 miles. So that means that at time 0, the point that we're given is 0, 0. So that means that p of 0 should be equal to 0 when you have negative 6x squared, so you have 0, plus 0 plus c. So c is equal to 0. So this means that p of x is equal to negative 6x squared plus 96x. Now the problem asks how far the car has traveled when it comes to a halt. Now because I don't have any space here, I'm just going to say that it traveled p of 8 miles. Where in reality though, on a test or something, you would have to compute that by plugging in 8 into the function. Today we learned about initial condition in calculus. Thank you for watching this video.